Hey, Chemistry 12, welcome to day one. Sorry I can't be there. We are going to be going over the Chemistry 11 review. So these are things that I kind of expect you to be able to do for Chemistry 12. Hopefully you didn't have too much of a problem with this. I do want to go over it because I want to make sure that if you are making a mistake, you know what mistake you're making and you can fix it accordingly. Okay, so hopefully you should have your periodic table and a calculator in hand and a pen or pencil or something like that. Anyways, first one, answer number one. I'm just going to change my pen color to red. So this one right here is what? Okay, that was a mistake. Okay, this one right here is magnesium oxide. That's it. No number because it's not multivalent. This one right here is manganese 2 sulfide. It does get the number because manganese is multivalent on your periodic table. This one right here, iron is also multivalent. So it's iron sulfate. SO4 is sulfate, and iron is multivalent, so it deserves the number. Sulfate is 2 minus, so that means iron has to be 2 plus, so it's iron 2 sulfate. And this one right here is copper phosphate. Phosphate is -3, and that means copper is +2, so that's copper 2 phosphate. And for this one right here, we have sodium acetate. Sodium is not multivalent, so no number. And then we have these 3 waters, or in other words, trihydrate. And right here, calcium is not multivalent, so it's just calcium nitride. Okay, hopefully you did that. Okay, write the formula of this. Sodium chloride, zinc sulfide. Zinc is 2 plus, sulfide is 2 minus, so therefore there's no numbers there. Lead is Pb, oxygen is O. Lead is 4, oxygen is 2 minus, and then common denominator, take a 2 out of both of them, so it'd be PbO2. Okay, so if I did that too fast, again, Pb, it says it's 4 plus, oxygen is 2 minus. When you swap and drop, Pb2O4, take a 2 out of each one of them, reduces down to PbO2. Okay, so hard to read too. Tin is Sn. Okay, sulfite is SO2 and SO3. SO3 is 2 minus, and tin is it says it's 2 plus, so it'll just be like that. Tetra is a fancy way of saying 4, and then hydrate is a fancy way of saying water. Okay, ammonium is NH4. NH4 is +1. Hydroxide is -1, so therefore no numbers. Calcium is +2. Oxygen is -2, no numbers. Okay, here I have a balanced equation, and it says that you have 15 grams of HCl. How many liters of chlorine gas will be made at standard temperature and pressure? And so we're going to do some stoichiometry right here. Since it's standard temperature and pressure, that number that you should be knowing is 22.4 liters is equal to 1 mole. That only holds true at STP. And so, yeah, anyways, let's get into it. So we have 15 grams of HCl. Nibala would say go over the mole bridge. And so in other words, what we're doing is we're converting it to moles. So we want 1 mole over, and then I need to find the molar mass of HCl. So Cl is 35.5, hydrogen is 1, so 36.5 grams. So now I'm in moles of HCl, and now I'm going to convert it into moles of chlorine gas. It's a 2-to-4 ratio, and so that means it's going to be 2 chlorine gas over 4 HCl. And now, if I just did this calculation, I'm in moles of chlorine gas, and I want liters. And then whatever we get for this. So just to recap, 2 sig figs, 3 sig figs, 2 over 4. These are exact numbers. So it's no sig figs, and 22.4 is 3 sig figs. So our lowest number of sig figs in this equation is 2 sig figs. So our answer will be 2 sig figs. So I'm going to go 15 divided by 36.5. Then times 22.4 equals, and I got 4.6.
Excuse the interruption.
Oh.
Any teachers or leadership students, if you have not received your lunch, please come down to the caf and grab it.
Oh, dang, there's lunch. I'm going to have to put this video on pause pretty soon and go grab something. But we were saying 4.6 liters of chlorine gas. Okay, 2 sig figs, remember. Okay, let's finish this so I can go get lunch. Okay, you make 25 grams of water. You make 25 grams of water. How many particles of O2 was used? Oh, so it's from the previous question still. Okay, so 25 grams of water. When in doubt, mole it out is what I always say. So we're going to convert this into moles. 18.0 grams. O is 16 and 2 H's is 1 and 1, so 18. So I have 25 grams of water, and how many particles? Remember, 6.02 times 10 to the 23 particles is equal to 1 mole. Okay. And so water, and then I'm going to go times by, we have 2 water is equal to 1 oxygen. So by this standard right here, I am now in moles of oxygen gas. And I don't want to be in moles of oxygen gas. I want moles of, I want particles of oxygen gas. Okay. Just I should have done it with the first one here, but what you should be doing is just make sure that you did everything right. Cancel your units. Grams cancels with grams. Water cancels with water. Moles cancels with moles. What's my unit that is left? Particles of oxygen. Particles of oxygen. That's what I want. And so I make sure my units give me that. And anyways, 25 divided by 18 divided by 2 times 6.02 times 10 to the 23 equals 2 sig figs is my lowest number I have, so my answer will be in 2 sig figs. I have 4.18, which will go to 4.2 times 10 to the 23 particles of oxygen gas. You start with 3 moles of HCl. So we have 3 moles of HCl. So we're already at the start of the mole bridge, so we don't have to convert it to moles. It gives us moles. How many moles of water can you make? Oh, and it's a 4-to-2 ratio. So I want my HCl to cancel out. So I'm going to put HCl on the bottom. And it says that it's 4 HCl. And I believe it says 2 water. Okay. And again, HCl cancels with HCl. I'm in moles of water, and that's what I want. I want moles of water. So nice and easy. 3 times 2 is 6. And divide by 4 is going to be 1.5. Okay. Box. Find the molar mass of glucose. Carbon is 12. Okay. Hydrogen is 1. Okay. Oxygen is 16. Okay. So times that by 6, times that by 12, times that by 6 as well. Okay. Um, and so 6 times 12 is 72. And so it'd be 72 plus 1 times 12 is 12. And then 6 times 16 is 96. Okay. Add those things up. 180.0 grams per mole. It should be 4 sig figs. Because like technically what you're doing for this when you do molar mass is that you're seeing that like, hey, there's 6 carbons and it's 12.0, and you're going 12.0 plus 12.0 plus 12.0 6 times, and then you're going hydrogen is 1.0 1.0 12 times, and then oxygen is 16 16.0 16.0 16.0. But when you're adding them all up, I should be putting 6 12s, 12 ones, and 6 more O's or 16s. When you're adding them all up, they all have 1 decimal place, so your answer needs to have 1 decimal place.
Grade 8 students, at this point, can you please make your way into the first 2 sections of the bleachers in the gymnasium, the same seats we were using this morning?
Okay.
Grade 8 students, if you can make your way to the first 2
Sorry
seats.
about that.
Please make sure any garbage you have on your tables gets into the garbage cans, recycling into the recycling containers. We want to leave this area nice and clean.
Yeah, okay.
Mr. Ray,
Sorry.
who is also the person that comes over and helps clean up your school.
Okay.
So please make sure it's all neat and tidy over there. And then the first 2 sections of the bleachers, please.
Okay. So a good video editor would edit that stuff out. I'm just gonna leave it in. Okay. Anyways, C6H12O6. So we have 11.2 grams of glucose. How many particles of glucose is there? First thing we have to do is we need to change this into moles. 1 mole. Thankfully, we've already found out the molar mass of this stuff is grams. I want to have the grams on the bottom because I want grams to cancel out. And I now want moles to cancel out. And we know that 1 mole is equal to 6.02 times 10 to the 23 particles. Okay, so 11.2, which is 3 sig figs, divided by 180.0, 4 sig figs. I didn't write the 0.0 in there, I should have. And then times 6 point, oh shoot, I put the wrong number in there. 11.2 divided by 180 equals, and then times 6.02 times 10 to the 23 equals, and I got 3.7458 times 10 to the 22 particles of glucose. Now, 3 sig figs, 4 sig figs, 3 sig figs. My answer should be in 3 sig figs. So it's going to be 3.7. That rounds up to 5 times 10 to the 22 particles of glucose. That's my answer. Okay. How many significant figures are present in the following numbers? These numbers right here are significant. This should be a 4. These numbers right here are significant. This should be a 4. Trailing zeros are not significant. Leading zeros are not significant. Okay, so these ones are not significant. There's no, this is 4 right here. Okay, now this looks like it's a trailing zero, but it's after a decimal place, so this is significant. And so that's also 4. Like, and if that confuses you, D, it's significant. I want you to think about this. Like, if someone said like, oh, how much money you got in your wallet? And they're like, I got $100. I got $100. Okay. That means it's pretty rough number. It's somewhere around there. That's 1 sig fig. But if someone says, how much money you got in your wallet? And they're like, $100.0, right? That's a way more exact number that has more significance to it. That implies that they know exactly what they have. So that's 4 sig figs. Now, this number right here, scientific notation doesn't count towards significant figures. So this is just 2 sig figs. Okay, which of the following is an exact number? Distance, mass, volume, length. These are all measurements. Okay, these ones all have. There's nothing that's perfectly 118. It could be 118.1 centimeter. The only thing that's exact numbers are counted. This is the only thing that was counted. Okay, everything else is a measurement. So these have significant figures. This one, this one, this one, and this one. This has no significant figures. Write an answer with the correct number of sig figs. 2 sig figs times 1 sig fig will be 1 sig fig. So 12 times 10 is 120. Convert that to 1 sig fig. 100 is the answer. Okay? So if you wrote 100, correct. If you wrote 1.0 times 10 to the 2, incorrect. This is 2 sig figs. We need to have 1 sig fig. Okay? So you could be weird and go 1 times 10 to the 2. This is also correct. Okay? But this is not. This is definitely not. 12 times 12 is 144. Okay? But we have 2 sig figs and 2 sig figs. So this needs to be 2 sig figs. So our answer would be 140. I changed that to 2 sig figs. 6 times 6 is 36. Okay? 1 sig fig, 1 sig fig. Change this to 1 sig fig. The answer is 40. That's 1 sig fig. Okay. 29 plus 10. Okay? So this is, you have to do a different rule right here, not just counting number of sig figs. So we're going to go 29 and 10. Significant figure, significant figure. Okay? Now, I like to call it the line of significance. Right here is my line of significance. I just added up normally like I would. That'd be 39. But this number right here is significant. These numbers right here are insignificant. This is above 5, so it's going to round this one up. So it'll be 40 as well. Okay? Now, here's where it gets a little bit weird, is that we have 1,400 minus 55. And so what we have to do right here is we have to do the same principle and draw our line of significance. So significant, 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 significant. These ones are not. So my line is going to be right here. I'm just going to do my math like I normally would. Okay, so I get 1,345. Now, everything on this side of that line is insignificant. Everything on this side is significant. Insignificant. So that means since the 45 or 4 is below halfway, it's not going to round up that 3. So what is the answer right here? Is 1,300. Okay? And that's our answer. Hopefully that makes sense. Now, I wanted to give like one more question for significant figures. Let's say you had like 120, okay? And you subtracted minus, say we went minus 7. Okay? So significant, significant, significant. Our line of significance would be somewhere right about there. And this would be just subtracted like we normally would. That'd be 113. Okay? Now everything on this side, we're going to get rid of, and it's below 3, so it doesn't round it up. So 120 minus 7 would be 110. Even though that 7 is just 1 sig fig, our final answer is 2 sig figs. So that can happen. Okay? That's just the way it kind of works. Hopefully you had all the right answers, and if not, hopefully that kind of clarified a few things. But yeah. Oh, there we go. Now I can stop